The quadratic formula. The quadratic formula is a really nice way in order to solve any quadratic equation. There are other ways to solve quadratics, but in this formula, it works every single time. Now you say, why would you want to use something that doesn't work every single time? Well, sometimes when you're using the quadratic formula, the pieces and steps can be more difficult than if you had been more direct with factoring or extracting square roots. But this is one of those that will work every single time. There are some cases that it's the only one that's going to work. So that's why we need to cover all our bases. What is the quadratic formula? The quadratic formula is x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And now let me share a little song with you to help you to remember that.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you try. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
Elementary as that song is, that will help you to remember that formula and know those pieces. Now, what do we even do with this quadratic formula? What we're trying to do is we are trying to solve for x, right? That's our big main math goal, is to solve for x. So with the quadratic formula, it gives us a way to solve for x when x is being squared in this case. So the best thing we can do is just jump right into some examples and see how all these pieces are going to pan out. Now, whenever you're working with your quadratic formula, your quadratic needs to be in that standard form of ax squared plus bx equal to c, so that you can recognize your a, b, and c coefficients. That is where all of these different letters are coming from. So first step in any of this process is make sure it's in standard form. If it's not, move everything over, get it set equal to 0 so you can do that. So let's just jump in. So in our example, 9x squared plus 3x minus 2 equal to 0. First, let's identify our a, b's, and c's. A would be 9, b would be 3, c would be negative 2. When you're recognizing what your a, b's, and c's are, you do not use the x squared or the x. You just take the large number that's placed in front of it. If you don't have a number in front of the x squared or x, it's an assumed 1. If you do not have a constant term, then that's a 0. In order to work the quadratic formula, here is what I would recommend. First, write your formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. After you write your formula, rewrite it with blank parentheses anywhere that you had a letter. Hopefully, the more you see it, hear it, do it, the more you will retain this formula. It's something that we're going to use quite a bit. And so now that I have my formula, I have something to look at. I'm not trying to pull it from my memory and fill it in at the same time. I have it all written down with blank parentheses everywhere I had a letter. Now I'm going to go and I'm going to grab those values that I already identified of 9, 3, and negative 2, and I'll write those down. So let's see, b was 3, so I'll plug in 3 here and here. A was 9, so I'll place a 9 here and here. And c was negative 2. Be careful with those little negatives. They do need to go along as well. Now that I have everything filled in, what I'll do is I will take and I will condense this part underneath the radical and use my calculator where needed. So x is equal to negative 3. Now 2 times 9 gives me 18, plus or minus the square root. I would just pop over to my on-screen calculator and enter the purple part that we just highlighted. So that gives me 9 plus 72, or a total of 81. Again, I would not plug in this entire situation. I would only use the part that's underneath the radical. Then we can see that we have a much shorter problem. So then we can begin to clean it up. I'm next going to go to my calculator and I'm going to say, okay, negative 3 plus or minus. I'm going to try and see if 81 is a nice square root. Nice meaning gives me an integer, not a decimal answer. So the square root of 81 is 9 all over 18. Now, once I get to this point, this plus or minus means I'm going to have to add the 9 and then subtract the 9. So this is where I'm going to go ahead and split this process and say, well, negative 3 plus 9 over 81, negative 3 minus 9 over 81. So negative 3 plus 9 gives me 6. Excuse me, I switched that over. Hopefully that caused a red flag for you of where did she get that 81 from? Over 18. And so 6 over 18, that would reduce down to 1/3. So there's my first answer. Or the answer could be negative 3 minus the 9, which gives me negative 12 over 18, which reduces to negative 2 over 3. And so you can see with the quadratic formula, it does always work, but you have to be careful with your steps. And I'm just going to try and give you the best advice I can to work this process every single time given any numbers. So we can't end with one example. Let's do another one. First step, I'm going to identify my A, B's, and C's. A is going to be 1. There's an assumed 1 here. B is 5, and C is 1. I'm going to write my formula. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Next, rewrite your formula with blank parentheses anywhere you have a letter. After you write it with all those blank parentheses, go back and fill in your values. So B is 5, A is 1, C is 1. Next, just calculate this value here that's under your radical. So that gives me x equal to negative 5 plus or minus the square root. 5 squared minus 4 times 1 times 1. Again, I'm just going to plug that in exactly like I have it highlighted, and that gives me a value of 21 all over 2. Now, this is all over 2. I cannot divide underneath that radical, but let's go back and let's look at the square root of 21. This is 3 and 7. These are both prime, so I actually can't break that part down anymore. So I'm ready to go ahead and tell you what my answers are. This would be negative 5 plus the square root of 21 all over 2, comma negative 5 minus the square root of 21 all over 2. Now, if you want to split that up and actually divide it, so that is a correct answer. You could divide everything by that 2. That gives you negative 5 over 2 plus the square root of 21 over 2, but you can't divide underneath that 21. Like I'm not going to put a square root of 10.5. And then the other answer is negative 5 over 2 minus the square root of 21 over 2. And again, either way, I'm getting 2 answers. It does look a little complicated. Now, the first example here, the fact that we got 1/3 and negative 2/3, I could have factored that and I could have solved it. The fact on the second one that I got this square root of 21 means that quadratic formula was definitely the way to go. And the way that's going to be able to work that out, it wouldn't have factored. Let's work another example. Okay, so this one is a quadratic, so I can solve it using a quadratic formula. First thing I need to do is I need to get it into standard form. This is not equal to 0, so I'm going to have to subtract the 9 over. That gives me 2x squared plus 6x minus 9 equal to 0. I now have it in that standard form like we mentioned. Ax squared plus bx plus c equal to 0. So I can now correctly identify a to be 2, b to be 6, c to be negative 9. And I'm going to, like the previous two, quadratic formula, negative b plus or minus the square root, b squared minus 4ac all over 2a. Next step, I'm going to rewrite it with blank parentheses anywhere I have a letter. This is going to help me with my negatives, help me with placement, help me I don't mess anything up. I'm going to fill in my A, B's, and C's. This gives me 6, 6, 2, negative 9, 2. I'm just using those A, B, C values. I'm going to take and I'm going to plug in this entire piece into my on-screen calculator. So this gives me x equal to negative 6 plus or minus the square root of 108 all over 4. Keep making that square root pretty big there. Now I need to break down 108. Now I would go to my calculator and see if it square roots like the 81 did earlier, But in this one, the square root of 108 gives me a decimal, so that's how I know I need to come over here and do a prime factor tree. Now it's an even number, so I just break it to 2 in itself. I'm going to take 54. That breaks into a 2 and 27. 27 breaks into 3 and 9. And I'm just circling the primes as I go. Break apart the 9, which gives me 3 and 3. So the square root of 108 is equal to 2 times 2 times 3 times 3 times 3. So that means a pair of 2 can come out, a 3 can come out to give me 2 times 3 times the square root of 3, or 6 square roots of 3. Now the reason, you may not be super fond of this, the reason I did all this over here is so I could reduce that radical. This gives me negative 6 plus or minus 6 square roots of 3 over 4. Now I can't divide underneath that radical, but I can look at these pieces and possibly reduce them, which gives me x equal to, they'll all divide by 2, so negative 3 plus or minus 3 square roots of 3 over 2. This is an exact answer. I did not want a decimal number. I wanted an exact answer of what that x is equal to. If I go to plug it in online, I get negative 3 plus 3 square roots of 3 over 2, and x, negative 3 minus 3 square roots of 3 over 2. Those are my two x answers. And again, I couldn't have factored this or complete the square. This is an exact answer that I would have had to get. Hope this helps with your quadratic formula. Go and attempt the problems and then reach out to your instructor if you need assistance.